Welcome back to our channel. In this video, let us simulate Phyllotaxis pattern using JavaScript. Plants can grow new cells in spirals such as the pattern of seeds in this beautiful flower. The spiral happens naturally because each new cell is formed after a turn called golden angle, that is 137.5 degree. The interesting behavior is observed in flower seeds, leaves, branches and petals. We have seen how the Phyllotaxis pattern will look like. Now let us understand the geometry for drawing this Phyllotaxis pattern. To place a dot in the boundary of a circle, say at xy as placed in this picture, it depends on r and theta, where x is equal to r times the cosine theta and y equal to r times the sine theta. So by placing dots on this circle, we will be able to get our Phyllotaxis pattern, provided r and theta is also varying. R as a function of c times square root of n, where n is the number of dots we are going to place and form a circle. C is a constant and theta is n times the golden angle, that is 137.5 degrees. So with this golden angle, we will be able to get our Phyllotaxis pattern. Now coming to the HTML portion, I have the canvas of ID Phyllotaxis and background color is set to RGB 448 and 39. Let me come to the JavaScript portion and have the canvas by using get element ID Phyllotaxis in a 2D context, and let me also get the canvas width and height, which is nothing but the window's inner width and inner height. Let us have the variable initialized here with n as 0 because n is the number of dots that we are going to draw to get the Phyllotaxis pattern. And first let me declare the constant c as 7, and I am also setting the font for our context. Let me call a function draw. At first let me increment n every time when this function is called until n is less than 1000 times. On reaching 1000, let us not call the timer. So until less than 1000, n less than 1000, we will call this function draw recursively once in 25 milliseconds. Now we have set the context for this function. By varying r and angle, we will be able to get changed xy positions on the circle, and hence Phyllotaxis pattern will be made. So first angle is nothing but n times the golden angle, n being the number of dots initialized here to 0 and which will be incremented every time this draw function is called. 137.5 is the golden angle and r is c times the constant times the math square root of n. Now we will start calculating x, y values. Before that, let me have the fill style for our pattern, and let me fill the text as dot. Here already I have set the font as 70 pixel Georgia type, so this dot will be of 70 pixel, which will look like as a circle for us. Now variable x and y are dependent on r and angle, where variable x is equal to r times cosine theta plus I am going to take canvas width by 2 because every time we want to start from the center. Center is where 0, 0. The angle has to be converted into degrees here. So before taking cosine, let me multiply the value of angle with pi by 180 degree. Same way for y coordinate, it is r times the sine theta in degrees plus canvas height by 2, so that it also starts from center. The golden angle here is 137.5 degrees and the dot will be placed at xy of 70 pixel. I have also given the fill style. Now we can see the Phyllotaxis pattern is visible on our canvas. We can change the fonts to C, as C indicates the spacing between the dots. By changing C and font, we could see the size of our Phyllotaxis pattern is changed. Please subscribe to our channel to get more views. Don't forget to like and comment below the video.